Okay, so there are 2 more pages in our notes sheet. This is page 3. The confidence interval for P when sigma is unknown. I don't think I meant to do that. I think I would scratch that off. We're just creating a confidence interval for P. And I have a little note here. We need to check and make sure that n times the sample proportion is bigger than 10, and n times q hat, which q hat is just 1 minus p hat, n times q hat needs to be bigger than 10. So this is just making sure that the sample size is adequate. And this is only going to fail in cases where our results are getting really low percentages. So if you're talking about a situation where only 1 or 2% of people are going to say yes, then you're going to have a much larger sample to study. So we'll check to make sure that that condition is met for this problem. A political science student wants to estimate the percent of students who are registered voters. He surveys 500 students and finds that 300 are registered voters. Compute a 98% confidence interval for the true percent of students who are registered voters and interpret. All right, well, let's take a look at the information that's provided. This is our n. This is our x. What is our 98% confidence interval? Well, there's our confidence level, 0.98. P hat is 0.60, and so Q hat is 0.40. And that allows us to step aside briefly to check that this condition is met. What is n times P hat? So that would be 500 times 0.40. 500 times 0.40, 200. Is that bigger than 10? Sure. What about 500 times 0.60? Because that's Q hat. Yeah, so this condition is met. There's no problem with that. Our sample size is totally adequate. What about alpha? Alpha is 0.02. It is 1 minus the confidence level. So I don't think we really know that, especially since we're going to be using the table from page 1 to get our z-score. So because we're using a 98% confidence level, I can zip back to locate my table value, and there it is, 2.326 is the z-score that I need. And there it is, 2.326. And you might be wondering why we're using a z-score here. Well, for population proportion problems, we always use the z-score. We never use a t-score. All right, so now we're ready to calculate the EBP, which is z times big square root p hat q hat divided by n. So we plug in, there's our z-score, 0.6 times 0.4 divided by 500, take the square root of that, and then multiply. So 2.326. Actually, you know what I'll do? I'll do 0.4 times 0.6, enter, divide by 500, enter, and then I get a really tiny number, and 4.8 e negative 4, I'll just take a sidetrack to show you that 4.8 e negative 4 really means 4.8 times 10 to the negative 4th power, which means 0.00048. There are 1, 2, 3, 4 jumps. You start at 4.8 and then you do 4 jumps to the left, which ends up with 0.00048. That's what this scientific notation number represents. I don't need to worry too much about that, but I do need you to know that that's a tiny number. Then we do second square root of the answer, second answer, enter, and then we multiply by 2.326, enter, and I just got my EBP. It is 0.0510. So there's my EBP. That's the thing that I'll be doing plus or minus with. My p hat was 0.60, so 0.60 minus 0.0510, and then 0.60 plus 0.0510. So those are my boundaries for the confidence interval. And sure enough, I said that we estimate with 98% confidence that the population proportion of students who are registered to vote is between 54.9% and 65.1%. I do encourage you to register to vote. It's, I think, too late to vote for the upcoming primary election this year. Well, depending on when you're watching this video, but it's always a good idea to update your registration and make sure that the ballot comes to you. Okay, so we can also get this result using stat tests. This time we're going to go to 1 prop z interval, which is all the way down on letter A. 1 proportion z interval. X was 300, N was 500, and our confidence level was 0.98. And if we calculate it, there are the values that we got before. So that confirms that we did the process correctly. On the rest of this page, I'm going to show you 2 formulas to tell you what sample size is needed. I'm going to erase this stuff here. What sample size is needed, or how many people do you need to survey? And one rule here is that if you get a decimal, you always round up. Like even if you got a result that said 55.1, you would say, okay, to be on the safe side, I'm going to round up to 56. So 2 different formulas, and again, what this is giving me is the sample size needed, N. And this would be something that a researcher would need to know. N is equal to z squared sigma squared over EBM squared. Or, if you're talking about a population proportion, z squared p hat q hat over EBP squared. And if you don't have the sample proportion yet, then you can use 0.5 for both as a conservative estimate. Okay, so question 8. The population standard deviation, that means that sigma is 3, so I like to write that down. We want to be 95% confident, okay, there's our confidence level, that the sample mean height is within 1 inch of the true population mean height. So that means that our EBM is 1. So I've transcribed all that information here. I made a note that if the confidence level is 1.96, then Z is, 0.95, then Z is 1.96. Something I didn't clarify, and I should, is that we are using Z-scores because we know sigma. We know the population standard deviation. If we did not know sigma and we just had S, then we would use t-scores. By the way, I don't have a formula for what the sample size should be if we don't know sigma. So actually, that's not going to come up. All right, n is equal to z squared, sigma squared over EBM squared. So did I plug everything in here correctly? Z squared, sigma squared, EBM squared. So I just need to do 1.96 squared times 3 squared, and then dividing by 1 doesn't actually matter. So I get a sample size of 34.57. So that I rounded up to 35. You would need to sample 35 or more basketball players to get within 1 inch of the true population mean. And the following question on the next page is also a question where you're determining the sample size needed. So I'll do that one next.